Good morning, students.
Here we go with polynomial long division. Long division is a stretch back to like 3rd grade here. We're going to start off doing like a 3rd grade long division problem. Now, long division does not have to be long because of the amount of time that it takes to complete the problem. It's usually long because as you are solving it, you do your work in a long fashion. Make sense? So don't get confused, because people always go, oh, I don't want to take the time. Well, sorry. Suck it up. Okay. First one. By the way, why are we doing division of polynomials? Because we already did add, subtract, multiply last week. Division's the last one we have to cover. It gets its own special day. So, dividing a polynomial by a monomial. That's the easiest one. What's the monomial that my polynomial is being divided by? 2x. So here's how I divide by a monomial. You ready? I put that monomial under each term. And then I simplify those terms. So instead of writing the divided by 2x here, I just put each one over 2x, and then I'm going to reduce the fractions. So what does 10x to the 3rd over 2x become? 5x squared. What does 12x squared over 2x become? 6x. What is 3x over 2x? 3 over 2. And 4 over 2x? 2 over x. And that's my answer. Yes, it's ugly. There's an x on the bottom. There's a fraction. That's okay. Done. Easy? Dividing by a monomial is easy. But you know it's not going to stay like that. We are going to divide a polynomial by another polynomial. Now, I am going to kind of mirror this with a 3rd grade problem. So, here is my 3rd grade problem. 277 divided by 12. Could be written like that. Could be written like that. Could be written like this. By the way, I noticed this I don't know when I decided this, but the division sign, if you change this into a number, that dot, and this into a number, it's a fraction. I know, genius.
You said it again?
No, you missed it. I'm sorry.
My attention spans.
You can watch it in the video.
Oh, yeah.
Anyway, so if you ever forget that a fraction is division, remember how similar it is to the actual division sign to remind you that it is division. Okay, end of that little side note. All right, so when you learned how to do long division, you said, okay, 12 can't go into 2, so I'm going to take these first 2 and say, okay, 12 goes into 27 how many times? 2 times. And then you would do 2 times 12, and that gets you 24. And then you would what? Subtract. See, you remember 3rd grade math. This is impressive. Now, I'm going to change your thinking a little bit about the subtracting. When you are subtracting something, you are technically changing the sign of it and adding it. Right? Subtraction is the same as changing the sign and adding it. So 5 minus 2 is 5 plus negative 2. Okay? It's a little awkward when you're dealing with numbers. When we're doing the polynomials, it's going to be more helpful for you to remember that we're going to change the sign instead of the subtracting part, because it's really the same thing. Okay, and then what would I do? Subtract. 27 and negative 24, or 27 minus 24, is 3. And then what would you do? Bring down the 7. And I'm going to say that's the end of the first cycle. Because then we repeat the process, right? We see how many times does 12 go into 37? 3 times. We put the 3 up there, and then what do we do with that 3? We multiply it. We write the answer down here. We do what? Subtract or change the sign. Right? And then I get 1. And depending on who your elementary school teacher was, you either wrote your answer like this, Remember that?
I remember.
My teacher had us write the answer like that. Here's how we need to get in the habit of writing it, though. Y over 12, because that remainder was the only thing that couldn't be divided by 12. Okay? So we're not going to do this R thing. That's kind of third grade.
If you can still divide that, can you still keep going?
Yes, that means that you could have kept going here.
Okay.
Okay? So let me show you how similar that is to polynomial long division. So here's polynomial long division. The problem could be written divided like that, or it could be written like that. But either way, you're going to set it up like that. Make sense? Same exact situation we've got over there, just not numbers. So here's how polynomial long division works. I am going to take the first term of that polynomial and the first term of this one, and that's how I'm going to get the number that goes on top. So I need to see x times what gives me x to the third. X squared. Now I'm going to write the x squared in a strange spot. Now there's a very specific reason why I wrote it there.
Oh, yeah, because that's 7x squared.
Because it's right above the x squared here. As you go through polynomial long division, you can keep things lined up. It will actually give you hints as you're going along as far as what exponents you need and such, depending on what column it is. Now, with that being said, this does need to be in standard form. So I do need a cubed column, a squared column, a first column or first power column, and then a constant column. Okay? So I got my number. When I got my number up there, what did I do with it? I multiplied it there and wrote the answer down here. Yeah? Not subtracting yet. Before I had a number to subtract, I had to get that number, that 24. So I took the 2 and I multiplied it by 12. So I'm going to take the x squared and I'm actually going to distribute it through this polynomial. So that's where the other part of this polynomial comes into play. So, watch. X squared times x is x to the third. X squared times 2. Notice everything is still lined up vertically. That's the long part. Okay. Now, what did I do once I got that number? I subtracted, or in other words, changed the sign. So what I'm going to have to do now is I'm going to have to change the sign of everything that I just wrote down. Not the number up top, but these two things down here. So this becomes a negative x cubed, and this is going to become a negative x squared. And then we do what? We actually do the adding or subtracting, if you will. X to the third minus x to the third, that's going to cancel, right? 7x squared minus 2x squared is 5x squared, so that's what I had there. And then what did I do? I brought down the 7, so let's bring down the next term. That's the end of cycle 1. Yes?
What if it was like negative 7x squared? Would you have to add it then, since you're doing the opposite?
It would be negative 9x squared. Because
Okay.
negative 7 plus negative 2 is negative 9.
So you always have to subtract?
Hmm?
You always have to subtract?
You're technically adding them together, the two numbers, because you've changed the signs of them. That's taking care of the subtraction. Okay, so we should do another cycle then. So now I'm going to look at this first term out here again, but now this is the first term I'm looking at. So x times what gives me 5x squared? Do you see all my x's are still in a column here? That's a good thing. That can give me a hint if I'm trying to figure out what the exponent needs to be. Look at what column that answer is going to go in. That'll tell you what the exponent needs to be. All right, so I got my number now. What do I do with it? Distribute it to there and there. So 5x times x is 5x squared. 5x times 2 is 10x. Now I'm going to subtract, and by subtracting I change my signs. That becomes a negative. This becomes a negative. And what happens? Those two cancel, which is good. 3x and negative 10x is negative 7x. One more term to bring down, plus 4. Now, yes, this one's taking a little bit because I'm going slow and explaining every single step. As you get going through this, you can do them much quicker, okay? Can I do another round? Sure. I have another column that could use a number. And here's kind of the general rule. When the degree of this guy down here is smaller than the degree of this, that's when you know you're done. Right now the degrees match, right? So I can still do one more round. You go until this is smaller in degree than that one is. Okay? So, one more round. X times what gives me negative 7x? Negative 7. What do I do with that negative 7 now? Distribute it. Negative 7 times x is negative 7x. Negative 7 times 2 is negative 14. Now I do what? Subtract or change my signs, which means both of these are going to become positives. So what does that leave me with? 18 would be a good number.
I said that.
Now, what's the degree down here? 0. Degree 0, degree 1. My degree is less than this polynomial out here, so I'm done. What I have down here is my remainder.
18.
So, here's what my final answer is. My final answer is x squared plus 5x minus 7. And then over here you could just write the remainder right next to the number, but in a polynomial we need to separate it by a plus or a minus sign. Since this is a positive 18, I'm going to put plus, and what is 18 going to go over? What could it not divide by? X plus 2. That's my answer.
Can't you reduce 18 and 2?
Good question. Can't you reduce 18 and 2? That's actually in a future chapter. No. The reason being, x plus 2 is technically in parentheses. It's a unit all by itself. And I can't simplify a constant with a binomial. I know that's not a great explanation. Wait for a couple chapters and the answer will be more clear. But for right now, no. Okay? So? Okay. Let's see. Do I want to do the remainder theorem right this minute? Sure. Okay, so here's this remainder theorem. I'm going to talk about this and then I'll do some more long division problems. If you don't want the full answer, you just want to know the remainder. Why would you just want to know the remainder? Well, if the remainder is 0, then we know it divides evenly, right? If it divides evenly, we have found one of the parentheses that would be used in factoring. Remember the snowflake?
Yeah.
Comes up with 2 parentheses. Well, when we did grouping, it had 2 parentheses. Well, we're going to get to ones that are going to have 3 or 4 parentheses. And if I can divide and get a remainder of 0, I've identified one of the parentheses. But only if I get a remainder of 0, because that means it divides nicely. So, can I check before I go through this whole process if I'm going to get a remainder of 0? And the answer is yes, that's this remainder theorem thing. So here's how the remainder theorem works. If I want to see what the remainder is, because ideally I want a remainder of 0, I look at x plus 2. If I set this equal to 0, x plus 2 equal to 0, and I subtract 2, I get x equals negative 2, right? If I plug negative 2 into the other polynomial, the result will be whatever the remainder is going to be.
That makes sense.
Kind of funky. So I take that negative 2 that I got there, and if I plug it in here, negative 2 to the third is negative 8. Negative 2 squared is 4, times 7 is 28, negative 8 plus 28 is 20. Minus 6 is 14, plus 4 is 18. That's what this work right here is showing. It's taking that negative 2 and plugging it in for x here, and when you solve that, you get a result of 18. So just by doing that, I can tell that is not a factor. So when you divide it, you're going to have a remainder with that fraction at the end. Okay? That theorem will be helpful more so in the next couple chapters. Okay? So we'll revisit that one as well. Okay? All right. G of x and h of x. Why do we use different letters here? What does g of x mean? What does f of x mean?
Function.
It means y, right? Y is a function of x. Or x is a function of y. I always get those confused. What does g of x mean?
Graph.
It means y. What does h of x mean? Y. So it's like all of these polynomials are named y. How do you tell one apart from the other? You give them different names. So it's just a different way of naming them to be able to tell one polynomial away from another. Okay? So they're saying find g of x divided by h of x. So find this y polynomial, divide it by this y polynomial. So they've got it set up for me. And what do you notice about the setup here? Anything strange? The what? The 0. Huh. Why did they put a 0 there? Well, remember how everything was so neatly lined up with the cubes? They had their column. The squareds had a column. The x's had a column. In this one didn't have an x squared term. But I need a column for the x squareds to go in. So if you are missing a term in that standard form pattern, you have to fill it in with a placeholder. What is 0x squared? It'd be 0, right? Because it's just 0 times something. So it's not adding a value, it's just adding a place for my x squareds to go. All right? Now, that is something that people always miss. So you might want to put a little star next to that or something, but people always forget that because it's a little tricky one that gets you there. All right, so let's do this long division. I have a longer polynomial out here. Does that change my process? No. The only thing it does is when I get my number up here and I distribute, I'm going to have 3 things to distribute it to. That's the only difference. So, starting off, x squared times what gives me 3x to the 4th? 3x squared. Look at that. Right off the bat, I needed that x squared column. If I didn't have that 0x squared, I wouldn't know where to put that 3x squared. What do I do now? Distribute. 3x squared times x squared would be 3x to the 4th. That's good because I'm going to want those to cancel. 3x squared times negative 3x. Negative 9x cubed. And 3x squared times 5 is 15x squared. Now, some people will try to save themselves some time and change the signs as they multiply. That gets very confusing. I really recommend just multiply, get your straight up answers, and then go back and literally change each one. It takes about the same amount of time, and it prevents a lot of confusion when people are going through that. Okay? So let's subtract. That cancels. Negative 5x cubed plus 9x cubed. What is that? 4x cubed. And 0x squared minus 15x squared. Minus 15x squared. And I need to bring down another term. Do I bring down one term or 2 terms?
One.
Just one. I want the same number of terms here as are out here. End of cycle 1. Moving on to cycle 2. All right, so let's see. X squared times what gives me 4x cubed? Let's use a different color. 4x. So now what do I do with the 4x? I distribute it. 4x times x squared is 4x cubed. 4x times negative 3x, negative 12x squared. And 4x times 5, 20. What do I do now? Change my signs. So, those guys cancel. I have negative 15x squared plus 12x squared, which gives me
3.
negative 3x squared. And 4x minus, that should be 20x. Sorry, my bad. 4x minus 20x, negative 16x, and bring down that last term. Is that my remainder, or do I have another round? I have another round. Why don't you try and do the last round? Figure out x squared times what gives you negative 3x squared, and go from there. Is that what you got for your three numbers? Negative 3x squared plus 9x minus 15. Change my signs. And let's see what I've got. Negative 16x minus 9x is negative 25x. And then negative 6 and positive 15 is positive 9. Am I done, or do I have another round? Am I done because I ran out of paper, or because the degree is less than this one? Because the degree is less. Okay? So, my remainder is kind of ugly, but that's okay. Let me show you how to write my final answer. 3x squared plus 4x minus 3. Now, whenever you have more than one term, like up here it was easy because it was positive 18. This one it's like, do I put plus, do I put minus, what do I put? Just always put a plus. Makes it easier. Put plus, this is my numerator, negative 25x plus 9 over what? X squared minus 3x plus 5, and that's what my answer looks like. Pretty ugly. It's an ugly process, but it's not necessarily a difficult process. Okay? All right, I want you to try this guy. So take a couple minutes and see if you can do this guy from start to finish. Okay? I'll give you a hint for those of you that need it. Start off looking at those two terms. 2a times what gives you 6a to the third, and then make sure you write that result in the correct column that you're using. Okay? I'm going to slowly work through this problem, but I'm not going to talk through it. So if you just need a hint, just glance up and see where I'm at. Okay? And if you see that I do something wrong, please let me know. Anyone want to check me so far? Am I doing good so far? Do I have questions? Okay. All right, how am I doing now? Is that what you got? Okay. I think I have one more round. What's going on here?
They all cancel out.
Which means I have a remainder of 0. I have something that divides nicely. So what's my answer? My answer is just 3a squared minus 7a plus 4. I don't have a remainder to write. So? Okay. Turn to the back. Okay. Kind of what I was talking about a little bit on this side with the remainder theorem. This is the factor theorem. A polynomial has a factor if that remainder, this is that remainder theorem, if the remainder is 0. That's what I'm saying. So, in this case, if I needed to factor this polynomial right here, I don't know completely how it factors right now, but I do know that one of the parentheses is 2a minus 3 because I got a remainder of 0. And the remaining part would be another set of parentheses that I could then use the snowflake on. Okay? So it takes us from a degree of 3 down to a degree of 2 that we can snowflake and use one of our other factoring methods on. Okay? And the only reason I can write it that way is because I got that remainder of 0. So, we're going to see, is this a remainder of this? Now, do you notice anything interesting here? Like maybe related to last night's homework? That's a difference of cubes. So let's see if we see anything familiar with that as we go through that process, okay? Now, it has lots of missing columns. I need some placeholders. So do you see this big blank spot? I have a cubed column. What do I need next? So I'm going to put plus 0h squared. That's my placeholder for the squared column. I also need a column for h to the first power. So I'm going to put plus 0h, and then I have my constant there. Okay? So if I look standard form, I now have 3, 2, 1, 0. I have 2 placeholders I need there. Kind of sort of makes sense? All right, let's divide. H times what gives me h to the third? H squared. Now I distribute. H squared times h is h to the third. H squared times negative 3 is negative 3h squared. Change my signs. And let's see. 0h squared plus 3h squared would be 3h squared. Bring down my next term, which is plus 0h. Now I repeat the process. H times what is 3h squared? 3h. So I get 3h squared, and I get minus 9h. Yeah? Change my signs. I have 9h minus 27. I think I can still keep going. Let's see, h times what is 9h? That would be plus 9. 9 times h is 9h. 9 times negative 3 is negative 27. When I change my signs here, what happens? Cancels out completely, meaning that I have a remainder of 0. So here's my question. Is h minus 3 a factor of h squared minus 27? It is. So if it asks, is the binomial a factor? Yes, it is a factor. Meaning if I were to factor h cubed minus 27, one of the parentheses would be h minus 3. What would the other parentheses be? H squared plus 3h plus 9. Now let me talk about that a little bit further. If I take h to the third minus 27, which was the original one, the factorization would be h minus 3, and then h squared plus 3h plus 9. is that the same factorization that I would get if I applied the difference of cubes process to the factoring instead of using long division? Exact same, right? First term minus that guy, then you square the h, multiply the 2, and square the 3. Okay, kind of makes sense. You could check it, you could multiply those out, and you'll see that you will end up getting h to the third minus 27. This is what that particular question was asking, though. Okay? All right, last one. Here's what the problem looks like. Now, there's a little problem with the number on the bottom. What do you notice about the polynomial on the bottom? It's not in standard form. So, I need to put it in standard form. I don't have to fill in zeros for the number out here, but I personally find it easier to fill in the zeros just because it keeps all my placeholders. If you don't fill in zeros out here, you may multiply and get something for this column and then something for this column. You'll have like spaces in there. So I like to fill them in out there just so that I get in the habit of doing it. So there's negative 2x squared. I have to put a 0x and then a plus 1. Placeholders just, I think, help out on the outside. On the inside, absolutely have to do a placeholder. Outside, it's optional if you can keep everything lined up. Okay? All right, so let's start. Negative 2x times what is 4x to the third? Negative 2x. So that goes in my x column. Now what do? Multiply it through. Negative 2x times negative 2x squared is 4x cubed. Negative 2x times 0x is 0x squared, right? And negative 2x times 1 is negative 2x. What do? Change my signs. 0, it doesn't really matter if you change your signs, but just to remain consistent, you should. Negative 8x squared minus 0x squared is negative 8x squared. And those two cancel, so I have plus 0x. Bring down your negative 17 and move on to the next cycle. Negative 2x squared times what is negative 8x squared? Positive 4. So let's see, I get negative 8x squared plus 0x plus 4. Change my signs. And what do I have? That cancels. That cancels. I'm left with negative 21. Is the degree smaller? Degree is smaller than here, so I'm done. So what's my answer? My answer is negative 2x plus 4. And then I could either do minus 21 over the original polynomial, or I could do, like I said, on the other side with the right here where I said you always put a plus. Either way, it doesn't matter. I don't really care. So this right here for right now is completely acceptable if you just want to do that. I would not put the placeholder in your denominator there. Yeah. Negative 2x squared plus 1. So you could write it like that, or you could write negative 2x plus 4 minus 21 over negative 2x squared plus 1. Either way. Okay. This is the way it's probably easiest to not make mistakes on, is to just always put a plus there. So, again, you can check it by multiplying. You can take this, that right there, multiply it by the original divisor, and then add your remainder, and you should get the same as the original problem. Okay? All right, let me pass out your homework. Happy studying.